Hi, thanks for joining me. Today I've got a fun problem from the Bulgarian National Olympiad from 2021. We want to know, does there exist a set S of 100 points in a plane such that the center of mass of any 10 points in S is also in S? So imagine we had, let's say, 100 coins, all of the same mass, and we scattered them on the XY plane. Could I put them out in such a way such that none of the coins are on top of one another, and that if I take any 10 of those coins, the center of mass of those 10 coins is in a position of one of the other coins? If you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so it turns out it's actually impossible to do this. It's impossible to lay out these 100 coins such that none are on top of one another and that the center of mass of any 10 is in the position of another coin. And I'm going to prove this by contradiction. So I'm going to suppose it is possible. And so I lay out my 100 coins on the XY plane and I position them so that supposedly if I take the center of mass of any 10 coins, it's in the position of one of the other coins. And I'm going to call these position vectors v1, v2, v3, and so on, all the way up to v100. So I've laid out my 100 coins in the position vectors of these 100 vectors. I'm just going to call that set v here. Okay, next what I'm going to do is look at the distances between pairs of these coins. So taking the pairs of coins, I'm going to look at distances between them, and in particular I'm going to look for the minimum distance, and I'm going to call that epsilon. So to define this slightly more formally, epsilon is the minimum of this set vi minus vj, where I and j are distinct. So I'm looking at the distances between two vectors, and obviously I and j are distinct because I'm looking at distinct coins, and this is a finite set, and so it's fair to talk about its minimum. That's well defined. And epsilon is obviously going to be positive because vi and vj are distinct and no coins are in the same position, so all these distances will be positive. Okay, in particular, because this is a finite set, I know that epsilon is going to attain the minimum for some value I and j, and to be honest, I can relabel these vertices if I want to, so without loss of generality, I'm going to assume that it's v1 and v2 is when epsilon attains its minimum. So epsilon is going to be the distance between v1 and v2. Okay, next what I'm going to do is take 9 other vectors, and they can kind of be whichever vectors I want as long as it's not v1 and v2, so I'm just going to take the next 9 vectors. So I'm going to call that set x, and x is a set v3, v4, all the way up to v11, which would be 9 vectors there. And what I'm going to do is consider x with v1 and also x with v2. Now, this guy here is a collection of 10 different coins or 10 different vectors, and so by our assumption that if I take the center of mass of these 10 vectors, it's going to give me the position vector of another one of the coins here. So if I take the center of mass of this, I'd add up all the vectors and divide by 10. So if I do v1 plus v3 plus v4 plus blah 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 up to v11 and divide by 10, that's going to give me the position vector of another one of the coins. Let's call it v alpha. And similarly over here, if I do v1 plus v3 plus blah 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 up to v11 and divide by 10, I'll get the coordinates of maybe some other point, v beta. And in particular, these 2 points will definitely be different. Oh, that's supposed to be a 2 there. And that's because v1 and v2 are different. And so therefore, these two are definitely going to be different because the only difference in the calculation is these guys, and these are different. Okay, what's the issue with this? Well, the issue is if I do v alpha minus v beta and look at the length of that, so the distance between v alpha and v beta, well, using this definition here, the v11s are going to cancel when I subtract them, so are the v10s, so are the v9s, and so on, all the way down to the v3s, and all I'm left with is a 10th v1 minus v2. And v1 minus v2 we're assuming is epsilon, so this is epsilon over 10. But hold on a minute, we found a pair of position vectors, or pair of coins, whose position vectors are epsilon over 10 apart. But this contradicts the fact that epsilon is supposedly the minimum distance between pairs of vectors, and we arrive ourselves at a contradiction. And that is the solution to this problem. It is impossible, and you can actually use these numbers. Nothing special about 100 here or 10. You can play with these numbers and get a slightly more general result as well. Anyway, we'll finish off there for today. Thank you for watching. I hope you have enjoyed. Please do give this video a thumbs up if you have enjoyed it, and if you are new to the channel, please do consider subscribing as well. Anyway, I'll stop waffling. Thank you for watching. I'll catch you in the next one. Have a great day.